Hello, this is John Masick. I am Senior Vice President at Bearing Service Incorporated, and today we're going to be talking about unmounted ball bearings. Special thanks to SKF for providing the information contained in this presentation, and at the end we'll talk a little bit more about other material that might be available through the Bearing Specialists Association. So let's get going. So today we're going to talk about all the different styles of unmounted bearings. And if you look here on the screen, you're going to see the bearing world is comprised of two different styles of bearings. Ball bearings, which have round steel balls typically, or it could be ceramic, or roller bearings with various different shapes of rollers. And here you see cylindrical, taper, carb, and spherical. Carb is a unique product to SKF. But all of the other bearings shown here are manufactured by a variety of different companies. The first one we want to talk about today is the DGBB. So what does that stand for? Well, that stands for Deep Groove Ball Bearing. And in fact, the one that they're showing here on the screen is showing a sealed bearing. And if you look at any bearing, whether it's a ball bearing or a roller bearing, they typically come with four different components as standard equipment, so to speak. If you look at the inner ring here, that's the inner race. This is the portion that goes onto the shaft. And then you have the outer ring, which is the portion that goes in the customer's housing. And then you have some type of rolling element. In this case, we're talking about a ball. And then most of the time, but not always, there's some type of retainer or cage that separates the rolling elements and allows for smooth rotation of the rolling elements throughout the inner and the outer race. In this particular bearing, these green objects here are seals. And if you look at the totally assembled bearing here on the left, you'll see that the seals are located here to protect the balls from contamination and also any grease that's in the bearings from leaking out. So you can barely see it, but there's a little green seal here on the left side and the big green seal on the right side. So this would be a double sealed ball bearing. A little bit about the terminology. So here you're seeing a cross section of a bearing. And again, we've got the inner race here. The inner race is the portion which it goes on the shaft, and you've got the outer race here, which goes in the housing. Some of the other machining that goes into a bearing is something called the land. The land is the flat spot here and here adjacent to the groove itself in both the outer race and the inner race, on which the seal or shield would typically ride or be mounted in. So more about that to come. The surface on the outside of the inner race and the outside of the outer race would be called the face of the bearing. And then the groove itself is typically called a raceway. So that is the area that is machined for the ball or roller to rotate through that bearing. The part numbers are usually indicated on the side face of the bearing. They could be on both the inner race or the outer race, or sometimes both. And like the previous picture showed on the seal, a lot of times the part number will also be there. The raceways themselves are the area in which the ball contacts with the inner race and the outer race. And that's really the working part of the bearing. That's where the ball, in this case, is going to roll. And that's where you're going to see most of the air or wear that goes on inside the bearing. The cage or retainer here, which is this little kind of vertical image, oftentimes will ride right on the land. It's not unusual to have a outer land riding cage or an inner land riding cage, although most technology now, they're going to a center or a ball riding cage. So the cage is an area where the lubrication can collect and be fed to the balls so that the bearing gets properly lubricated throughout the entire surfaces of the bearing between the ball and the raceways. Again, another look at a similar bearing here. Again, this is a deep groove radial ball bearing. So the reason it's called a deep groove is that this groove is large enough to be able to entrap this ball so the ball can't exit inadvertently out of the bearing. And here they're referring to a couple different ways to look at the inner race of the bearing. So this area here where the shaft would actually go is oftentimes called the bore of the bearing. You'll also hear it called the ID, or the inner diameter of the bearing. And the surface is the surface that would actually come in contact with the shaft. So bearings are typically mounted on a shaft. And then you have the outside diameter, or OD surface, which would be mounted in the customer's housing. And the width of the bearing is the width either through the outer race or the width through the inner race. Most often, they're very similar. There are a couple different types of bearings that have a longer inner race than the outer race, and then sometimes in a tapered roller bearing, the outer cup and the cone are typically not the same width. But in a deep groove radial ball bearing, almost always that width of the outer race, or the OD of the bearing width, and the width of the inner race are going to be exactly the same. This slide will show the different types of rolling elements that can be used in bearings. So we've already talked about the deep groove radial ball bearing, which is right here. And this little surface, or this little red spot, is trying to show you the contact that would be made between the rolling element and the raceways. And as you can see, it's a very small, a little bit bigger than the point, but it's a small circle. One thing that's unique about ball bearings is typically they're referred to as having point contact. And that means that in theory, that ball hits the raceway at 2 points, at the outer race and the inner race, at a single point. In reality, when that bearing is under load, that ball is going to create a surface contact that is actually a little bit of a circle and a little bit bigger than just a single point. And that enables that bearing under load to be able to take hundreds or thousands of pounds of load. The other 5 shapes that are shown here on the screen are all different versions of roller bearings. The spherical roller, and it's named for the fact that the roller here, if we continue this, would actually be a big sphere, a giant circle. So this is just a small arc of a big circle. The advantage of this particular bearing is that the area of contact is more of a line than a point. And in fact, it's a curved line, which means that it's got more surface contact than if it were a straight roller like the cylindrical roller bearing would. And also that spherical shape enables this bearing to have a unique feature to be able to be self-aligning. The spherical roller bearing asymmetrical, here this one here we're talking about a symmetrical roller. This one is asymmetrical, meaning that the diameter here on the right side is bigger than the diameter on the left. This roller shape is used in a spherical roller thrust bearing, which is kind of a unique bearing that is meant to support axial load rather than radial load. Cylindrical roller bearings are a kind of a barrel shape. So they have a straight roller. It is the same diameter on both the left and the right sides. And you've got an area of contact that essentially is a straight line. In this particular case, under load, that would be more of a rectangle. A needle roller bearing is just a skinny cylindrical roller bearing. There's various definitions, but typically the length of that roller is going to be at least 3 times the diameter of that, and that will make it a needle bearing. Needle bearings are the different shapes here on the screen is the one roller shape that is commonly available without using a cage. And so that makes that somewhat unique. It also makes it the bearing that can handle size for size the greatest amount of radial load of any of these bearings here. And then finally, you have a taper roller bearing or tapered roller bearing, where you have a the right side and the left side are of different diameters. So this contact point is on an angle, and depending on how big of an angle, how shallow of an angle, that will have various properties in terms of how this particular roller can support load. and we'll talk a little bit about load coming up. In terms of how the ball or roller contacts the raceway, here you can see that this ball is going to contact this curved raceway at a single point, but under load, that ball will compress, and the raceway, in fact, will deflect, and so you have a little bit of an area of contact, which essentially becomes a circle, and that enables a ball bearing to still be able to handle a tremendous amount of load, literally thousands of pounds of load on a bearing that's no bigger than my hand. This particular roller here, this looks to be a cylindrical roller bearing or a straight roller. Instead of point contact, we have line contact here shown in red. So the roller will contact the raceway at a line, and therefore the amount of surface contact on a roller is much greater than surface contact on a ball. And that enables a roller to be able to handle a lot more load than a ball bearing would. When you talk about naked bearings or unmounted bearings in general, and here we're showing a couple different styles, they have three primary functions, or a couple primaries and a couple secondary functions. The first one is to reduce friction. So if you look and compare a rolling element bearing to a non-rolling element bearing like a bushing, you have limited amount of contact points between this roller and the outer race, or the roller and the inner race here. And therefore, the amount of friction that bearing is going to see is going to be minimized. And at the same time, the materials of the steel are strong enough where it can still support a lot of load, but it can do so as it's rotating with creating a minimal amount of friction. And friction creates heat, and heat is the enemy of bearing life. And so by minimizing the friction, you can get bearings that can last a long time. The other thing that bearings do is they transmit loads. And we just saw in the previous slide that a ball bearing has more of a point contact or a small circle of contact, where a roller bearing is going to have line contact. And therefore, in this particular bearing, this is a spherical roller bearing. It's, in fact, a double row spherical roller bearing. You have line contact here on the left roller, and you have line contact here on the right roller. Because we have so much surface contact between the rolling element and the raceways, this bearing can handle a tremendous amount of load. And in fact, the spherical roller bearing can handle more load size for size than any other bearing can, if you take a look and account for the ID and OD combination. So many bearings, because of standardization, have the same bore size and available with the same outside diameter. There may vary in the width, but the spherical roller bearing of those naked bearings, other than that needle bearing I talked about, will handle the greatest amount of load overall. And here it actually explains a little bit more about what we're talking about in loads. There are three different types of loads that a bearing might see. The first one is called radial load, and it's represented by F for force, little r for radial. And this is a load that is actually perpendicular to the shaft. In this particular case, it shows the red arrow coming down through the outer race. The load would be supported by the ball squeezed between the inner race and the outer race here. But that load is perpendicular at a right angle to the shaft. The second kind of load is an axial load. Sometimes it's called a thrust load, represented by big F, little a here. And that is a load that is parallel to the shaft. And the picture here on the right shows a combined load. So in the real world, and you look at different applications that bearings are used in, you'll see that most often there'll be some combination of radial and axial load. It usually isn't radial only or axial only. For instance, if you have a pump is going to see by the weight of the impeller and the spinning of the impeller on the bearings, you will get radial forces. But because the impeller is going to be pumping things, you will get thrust load or axial load that will come along that shaft. So a pump is a good example of an application where you're going to see both radial load that's perpendicular to the shaft and axial load that's parallel to the shaft. Therefore, it's a combined load. And sometimes the bearing that's used will reflect that. There's different styles of bearings that do a better job than others in supporting both types of load at the same time. This is a really good chart that kind of shows you the relative comparison in load capacity, which in a bearing catalog is going to be represented by the letter C, which stands for the basic dynamic load rating. So dynamic load rating is the amount of load that the bearing can handle while it's turning before it would cause enough force to cause that roller or ball to dent the raceways and create what's called a Burnell. So the basic dynamic load rating, if you look and compare the spherical roller bearing, this is a tapered roller bearing, cylindrical roller bearing, angular contact ball bearing, you'll notice that it's a little different than this picture of a deep groove ball bearing. If you look at the shoulder here, you've got a thicker shoulder on the left side here on the outer race and a thinner shoulder on the other side. That's called a counter bore. And this bearing is set up so that this ball contacts the inner and the outer race at an angle. And that's why it's called an angular contact bearing, where a deep groove radial ball bearing is going to contact the outer and the inner race at basically 0 degrees at a perpendicular angle of 0. And then this one is unusual. It's a double row self-aligning ball bearing. The ball diameters, though, are quite a bit smaller. So it actually, even though there's potentially twice as many balls, the fact that it's considerably smaller diameter balls means that it can't handle quite as much in terms of dynamic load rating. So if you see here, the 3 bearings on the right with the smallest amount of load are all ball bearings, whereas the 3 on the left with the largest amount of capacity are all roller bearings. And in fact, the spherical roller bearing that has 2 rows of rollers, it handles the most dynamic load capacity of all other types of bearings. A little bit about bearings in terms of how precise they are. You may have heard that a bearing is more precise than a Swiss watch. And if you take a look here at some of the dimensions that they manufacture bearings to in terms of the tolerances. So when manufacturers are grinding the bore of the bearing or machining the outer race of the bearing, or even creating the diameter of the ball, they use a certain scale to determine the accuracy of the machining. And if you look here on the scale, you see that we have what's called a normal amount of precision. This would be a general industrial bearing that's used for a wide variety of applications. When you start to get here to a precision or a high precision bearing, we're talking about bearings that can go really, really fast and are very accurate and are used in mainly machine tool applications where they're doing very accurate machining to the 10,000th of an inch, which is 4 places past the decimal. So 0.0000. And since most bearings are actually metric in dimension rather than using 10,000ths of an inch, the metric system uses something called microns. And so this funny looking U with a stem on the left-hand side of it is a symbol for micron. And the way I like to remember microns is that each micron, or actually 2.5 microns, is equal to 1/10,000th of an inch, 0.0001. So this 15 microns means that this bearing tolerance would be accurate to 0.0006 thousandths of an inch. So it's 6/10,000ths of an inch. So if you compare that to a human hair is about 2.5 thousandths of an inch, 0.0025. So a bearing is about, even the standard industrial grade ball bearings are at least held to a tolerance that is 4 times more accurate than the human hair, or 4 times thinner than the human hair. So the machining is extremely accurate, and that's just on the standard grade bearings. If we're looking at aircraft quality bearings, it's 1/10,000th of an inch, or about 25 times less in diameter than a human hair. So bearings are machined extremely accurately. There is a grading scale that's used by manufacturers to determine how accurate the inner race and the outer race would be machined. And so we can know what precision bearing we're looking at to go into any particular application. And in fact, the grading scale, there's actually 2 scales, one that was developed in the United States and one that was developed in Europe and Japan. Both Europe and Japan use the International Standards Organization symbols, whereas in the United States, they use the Annular Bearing Executive Committee standards of 1, 3, 5, 7, and 9. In the ISO world, that compares to, actually normal is sometimes represented as P0. So you might see that once in a while, but normal, P6, 5, 4, and 3. So as the number goes down, that's equivalent to the US version of the number going up. So this P stands for precision, and as the number goes down, it reflects the fact that the precision tolerance range is much narrower on those. So the bearing is machined much more accurately. Another concept that's really important to know about bearings is something called internal clearance. So bearings have, from the factory, when they assemble them, typically a small amount of radial internal clearance. So there's a little bit of space between the raceway and the ball. So the diameter of the ball isn't quite large enough to take up all the space between the inner race and the outer race. And so why do you need this radial internal clearance? Well, you need it for several reasons. Bearings are usually, first of all, mounted on the shaft with an interference fit. So and that means that the shaft is actually physically bigger than the bearing. So you have to usually heat the bearing up to expand the inner race of the bearing. And when you do that, it uses up some of this radial internal clearance. The other thing it is used for is for thermal expansion. So steel expands at a rate of 0.000067 inches per degree rise of Fahrenheit per inch of shaft diameter. So as steel expands, the bearing grows, and usually the inner race is captured by the shaft and the outer race is captured in the housing. So where is that space going to be taken up? Well, the ball was also going to grow. So it's important to start out with a little bit of radial internal clearance here so that the ball doesn't grow bigger than the space between the inner and the outer race. And then it's not bad to have a little bit of space in there for lubrication to get as well. So all bearings are going to have a certain amount of radial internal clearance. And if you look at the scale here, you're going to see that they rate the increasing amount of internal clearance on a scale from C1 up to C5. Now, the outlier in this grading scale is there's something called CN, or normal clearance, also sometimes represented as C0. And that is considered something that it's got more clearance than C2, but it's got less clearance than C3. A couple things about this. All of these are overlapping tolerances. So this is a range of space between the bearing. And so we might have a few 10,000ths difference between the high point of clearance and the low point of clearance for a C3. And a normal clearance at the top of the CN clearance might be the bottom of the C3 clearance. So the ranges do overlap. The other thing that it's important to know is related to this picture here on the right. So a small amount of radial internal clearance will create a large amount of axial clearance. And so this enables this bearing, as a shaft would grow lengthwise, to be able to allow that inner race to be able to shift over in relation to the outer race and be able to compensate for thermal expansion. Now, that's still limited because if we talk about C3 internal clearance for a given size bearing, we might talk about 1,000th worth of internal clearance in that bearing. That might equate to 7 to 10 thousandths of axial clearance. But there will be some point in time where the bearing, if the shaft grew too long because of thermal expansion, you will use up all that axial clearance ability of that bearing, and what will happen is that bearing will start running hot. It will be under a condition called preload. It will no longer have internal clearance. It will actually have negative clearance in it, and that's a bad thing. If you don't control preload for a bearing, it tends to heat up and burn up very quickly. So internal clearance is critical. You match internal clearance for the application. Most applications, the most common clearance by far is C3. So a lot of times the bearing part number will contain the letter C3, and that'll tell you the internal clearance. If it doesn't show anything, then it's going to be considered normal internal clearance. You will not see CN, you will not see C0 on the bearing. If there's nothing on there as far as a clearance, then we assume that it's normal. So most applications will use C3 as the standard internal clearance. CN can also be used as a slightly less clearance for certain applications that don't have a lot of thermal expansion. But those are the two that you're likely to see. If you see a part number on there with a C3, then we know the internal clearance. If there is no C number on that bearing, then we can assume it's going to be normal clearance. Usually you're not going to go from one to another, but for most applications, it would be acceptable to go from normal to C3. And then C4 is probably the most common other clearance, and that's used for vibratory applications and applications where you're going to see a lot of heat. This is a chart that kind of shows a range of part numbers here on the left. So that is the designation column here. And it's showing various dimensions within that bearing. So let's pick the most common bearing here, which is a 6203, and that's in, I guarantee you, in mostly the electric motors in your house, whether it's your refrigerator, the alternator in your car. 6203 is the most popular bearing made. And if we look here at some of the dimensions, the first one we see is bore, and the bore is 17 millimeters, also represented here in the number of inches. And bore is typically represented by the letter small d. Then we have the outside diameter of the bearing, which in this case is 40 millimeters, and that's represented by the big D. So that is the outside diameter, or that's the outer race dimension of that particular bearing. And then the last dimension here they're showing is width, and that is 12 millimeters. So that's how wide the inner and the outer race are. We're also seeing here the amount of dynamic load capacity that bearing can handle, which is the amount of load that bearing can handle while it's operating. And this is in newtons, and this is in pounds. And newtons are about 4.5 times the number of pounds. And so if we look at that, this little bearing that is only about a little over an inch and a half in diameter can handle 2,200 pounds of load. So a relatively small bearing can handle a ton. So bearings can operate in environments where they're exposed to a lot of load and still be able to support that load and minimize the friction. So it's pretty amazing what they can do. The other thing that they're showing here is static load, which is the amount of load that the bearing can support while it's not turning. And you'll see in this particular case, the amount of static load capacity is actually less. And that's the amount of weight that a bearing can handle while it's sitting still before that ball would actually create a permanent dent in the raceway. And then you also have speed limits. So despite the fact that this thing can handle 2,200 pounds of load, it can also go 38,000 RPM. And that's the maximum speed, usually with oil. And then you typically have another speed rating that would be there, potentially with grease. You also have some other information related to how much that bearing weighs. So this is a very typical chart that you're going to see in most bearing catalogs. Bearings are listed usually in chronological number. You can see 6200, 1, 2, 3, 4, all the way up to 6208. There's some bearings here that are smaller in diameter that only have 3 digits to them, and that's really a different series. You might also see in catalogs other symbols that are after the part number. Here they're showing the letter Z to indicate a shield, or 2 Z's, or ZZ, or sometimes -2Z would indicate that the bearing has a double shield. You can see the little black kind of S-shaped or 2-shaped here would be the shield on the bearing. And it's not uncommon for bearings to be available with double shields, which are made of metal, or double seals, which are made of rubber that's coated over the top of steel. Or it's common to have rubber seals that are bonded to a steel shield to be a little bit more protective than a steel shield would. This is an interesting slide. It's called the bearing circle of life. So here I'm a bearing manufacturer out here, and what am I going to be concerned about? I'm going to be mainly concerned about making sure that I'm giving quality bearings to my customers. So I'm going to be worried about product quality, and I'm going to put a lot of emphasis in R&D. I'm going to research and make sure that the metallurgy is right, and that I'm using the best materials to seal that bearing, and I'm doing the best machining I possibly can to control that quality. But other things in terms of how that bearing is going to affect service life are going to be affected by 3 other things: the environment that it runs in, how it's installed, and how it's maintained. And if we look at the environment first and how we can impact that, first of all, it's really important that people who are dealing with bearings get maintenance training so that they understand how they can install those properly, but how that bearing is going to interact with the environment, how it's going to be affected by temperature or humidity or contamination or water. So all of those things can have an impact on bearing life. And so knowing what those are and having special solutions that are available, with maybe a special seal on a bearing or something to be able to make sure that bearing is going to hold up in that particular environment is critical. Then the end user has to worry about installation. Let's make sure we put it on right on the shaft. So again, I want to have my people trained properly. I want to make sure I have the right tools, and that when I do have issues with installation, that I have somebody that I can call for support. If there's a special way that bearing is going to be mounted using some type of a special device, say an adapter sleeve, then you want to make sure that someone's available to help the maintenance staff understand how they should properly mount that bearing. And then maintaining that bearing is critical. Again, having good training for your maintenance staff, making sure that they're using the right tools and making sure those tools are still calibrated properly and are taking and making the right measurements of temperature and diameter and pressure and water. Those are all tools that can help make sure that the bearings are going to be lasting to their rated life. And having people who are knowledgeable, having those industry specialists, I'll talk about that at the end. And making sure that if I do have problems with bearings, and let's say I need to replace a bearing, do I have the ability to maybe rework that bearing rather than replacing it with a brand new bearing? Sometimes with large diameter bearings, you're able to actually rework those bearings and do that more economically than buying new. So this is an interesting circle, but it really it starts with the bearing manufacturer making sure that they're making great product. But for bearings to really reach their end rated life, it's really incumbent on the end user. The person of the company is putting these into their equipment to do all the little things necessary to install it right and lubricate it during its life properly so that the bearing could see close to its rated life. Another circle of life issue is, what happens to a bearing and how do we make sure that bearing is going to see a good good amount of life. It starts with making sure you're using the right tools and disassembling it properly, because damage can be done to the shaft or to the housing if you're not taking that bearing out properly. But once we've got that bearing out, then we want to go ahead and look at it and figure out why it failed. And then we're going to want to put a new one back in there, and having the right tools, making sure the shaft is in good shape, making sure that the seal that protects the bearing is also in good shape is really critical to making sure that you're going to keep contamination out of that bearing. And then how am I going to lubricate that bearing? Really critical to make sure we have the right amount of lubricant, the right type of lubricant, and the right properties of lubricant, viscosity, and some other things, to make sure that that bearing is going to see the right type of lubrication for that particular application. So lubrication is very application dependent. And then when I go through and I mount that bearing in there, I want to make sure that the equipment is properly aligned, because bearings are supporting the shaft of the equipment. But if the equipment that let's say in this particular case, it looks like some type of motor here, if that's not properly in line with the pulleys or with a coupling that's attaching it to other equipment, that's going to cause strain on your bearings. And one of the ways, finally, that you can double check and make sure that bearings are operating properly is using condition monitoring. Here, someone's using some type of vibration analysis to make sure that that bearing is rotating properly, that there's no damage to the bearing, that it's running at the right temperature, and that the bearing application isn't seeing an excessive amount of vibration. Vibration is a good predictor of bearing failure, and so when you can minimize vibration, bearings typically will last much longer. Talk about some of the applications that bearings are used in. Probably the most common application is an electric motor. Again, I mentioned it before that in your home, in your refrigerator or your stove or your dishwasher or your car, your furnace, all of those have electric motors of some kind. And on each end of the shaft of an electric motor, there's a bearing. And usually it's a ball bearing, but on bigger motors, it could be a ball on one side and a roller on the other. But that is the number one application for bearings in the world. Other applications that bearings are going to be commonly used is a fan and blower. So, for instance, in plants, there are many, many fans. There's a need to exchange air in a plant. And so there's a lot of exhaust fans that are running constantly to make sure that fresh air is being circulated throughout the plant for the health of the people, and evacuate, bad gases and fumes and things like that. Other applications for bearings, conveyors are a really popular one. This is more of an incline conveyor at some type of looks like a gravel plant where you are bringing stone up here, and there's some devices here at the top, and right here there's an electric motor and a gearbox that are going to have bearings as part of the equipment that's going to help make sure that conveyor can move. Here I've got some type of crusher where I'm potentially grinding big diameter material into much smaller material. So there's a wide variety of different types of applications, but the rule of thumb is any type of machine that has a turning shaft is going to have a bearing on both ends. So if you think about every piece of equipment, your snowblower at home, it's got a bearing on both sides of that auger in your snowblower. So every application that has a turning shaft has to have bearing support on both ends of that. There's a lot of different options for bearings here. We see here, this is more of a normal size bearing, but take a look at these. These are really thin section bearings. So these are commonly used in robot applications where there's a limited amount of space between the wrist of a robot or the elbow of a robot. So in applications where there's a small cross section, they actually make bearings for that. Here's a big giant slewing ring bearing that would be used maybe on the turret of a tank. I think one time I sold a 20-foot diameter slewing ring bearing for that particular application. So bearings could be, in this particular case, big enough that someone could actually walk through a bearing. So a lot of different sizes. Bearings are also precision products, and they are meant to be handled very carefully. They can be damaged very easily if they're dropped. And one thing it says here is bearing failures are directly due to the environment. So if bearings aren't properly sealed and there's contamination that gets into those bearings, the bearings can fail very prematurely. So very important. Sealing, lubrication go right along with having a major impact, if not the biggest impact on bearing life. So making sure that you have knowledge of what environment a bearing is going into is really critical, so we can design that bearing in and have that bearing achieve a reasonable amount of life for that application. And again, here we're showing a satellite, but making sure we're choosing the right bearing for a vacuum environment or something that is off the wall or non-standard versus a standard industrial application. The reason that all those 6 shapes of bearings existed is because all of them are necessary for particular applications. There is now one bearing that is one size fits all. There are different styles of bearings for different purposes, and it's important that the engineers who are manufacturing equipment are knowledgeable about making sure that they design in the right type of bearing. So that concludes our talk today on unmounted bearings. I appreciate your time. If you're interested in learning more about bearings, the BSA, or the Bearing Specialists Association, has a program called CBS, or the Certified Bearing Specialist Program. And if you're a person who works at a bearing company, either a manufacturer or distributor, or you're an end user that is interested in really honing your knowledge at a high level about bearings, then please consult with BSA and look into the Certified Bearing Specialist Program. That concludes it for today. Thank you very much. I'm John Masick from Bearing Service, and I hope you have a great day.